I think that's
Okay,
good.
great. Melanie, thanks. Welcome, everyone. My name is Allison Campbell. I'm the current president of the Washington State Academy of Sciences, and I want to thank you for joining us for our kickoff webinar on growing with AI webinar series. For those of you who are not familiar with the Washington State Academy of Sciences, we are a scientific and technical advisory body established by law to serve the state of Washington, largely through our members who are top scientists and engineers across the state who volunteer their time and share their expertise on topics relevant to Washington State. Every year, we take a dive into important topics that are relevant to our state to learn more about what's happening across the state and how to explore how the research community can contribute to challenges and issues that are in our own backyard. For 2026, we're focusing on AI in agriculture. We hosted a symposium for AI on AI totality for Washington State, which is available. The summary of that symposium is available on our website. And we wanted to dive after that a bit deeper into explore AI in a relevant sector to our state. We chose agriculture because all of us depend on it. We all, eat food. The food producers face significant challenges given a certain number of external trends in economics and extreme weather. We feel it's an important topic for our state. The initiative starts with this webinar series where we learn together and continue with a workshop and development of grand challenges for AI in agriculture that will take place in the spring, with the intention of catalyzing new calibrations and investments to support a robust future for food production in Washington State. I want to thank the Washington State Department of Agriculture for their support of this webinar series, and thanks to all of you for taking the time to join us here today. With that, I'll turn it over to our Executive Director, Melanie Roberts, to kick off and begin the webinar. Melanie.
Great. Thanks so much, Allison, and welcome everybody. Like Allison said, today is the first of two overview sessions of our six-part webinar series. We have two overviews because we understand that you are all coming from really different backgrounds. Some of you know a lot about artificial intelligence already, but not so much about agriculture. And a lot of you know a lot about agriculture, but not so much about AI. And what we've learned is there aren't very many people who know a lot about both. And so we are hoping to change that through this webinar series where both communities will learn from one another and hopefully we'll find opportunities to learn together, to work together moving forward. Today's webinar is an introduction to the basics of AI to help us understand what AI can do now, what it might do in the future, and to hear about some initial examples of use cases in agriculture. You'll hear a lot more of these examples throughout the webinar series. We're really proud today to feature two leaders in computer science and AI in our state, one from UW, one from WSU, who I will introduce just prior to their presentations. We will have a 15-minute overview from each one of them, and then I'll moderate a discussion with both at the end. So please use the Q&A feature in Zoom to submit questions for the Q&A session at the end. Note also that we're recording these webinars. We'll make them, along with our speaker slides, available online afterward. And just before I introduce our first speaker, I'd like to recognize Renska Didoff, who's the Director of Programs at WSAS and staff lead for this initiative. Renska, is there anything that I missed or that you'd like to share?
I'll just add that I'll put some additional instructions for things like how to turn on closed captioning into the chat, which you can find at the bottom of your screen. But otherwise, I think we're good to go.
All right, let's get started then. I'm really pleased to introduce our first speaker, Oren Etzioni. Oren is Professor Emeritus of Computer Science at the University of Washington. His research has helped to pioneer powerful technologies, including metasearch, online comparison shopping, which I know you've all done a lot lately, software agents, and machine learning. He has taught thousands of computer science students, including in his popular current undergraduate course called Big Ideas in AI. Oren's also an entrepreneur. and has founded transformative for-profit and nonprofit endeavors to help develop AI for good and to revolutionize how we use computers and AI. He was founding CEO of the Allen Institute for AI, which is a nonprofit research institute, and founded and currently serves as technical director of the AI2 Incubator. He's founder and CEO of a nonprofit to fight deepfakes that use AI, and founded or co-founded a number of companies, including his current company, Vercept. With that, Oren, please take it away.
Here we go. Thank you, Melanie, and thank you, the powers that be, for unmuting me. I'm going to try and share my screen here so you can see my talk, my slides. Okay, hopefully you can see this as well. I've been working on AI for some decades now. I like to say that when I got started, people didn't even know how to spell AI. I will immediately confess to you, though, that I'm trying to put these AI ideas in the context of agriculture, or ag for short, but I apologize if my examples are hopefully naive, because I really know nothing about ag short of going to the supermarket and ordering some stuff. So let's start with what is AI? AI is basically a species of software. Of course, there's robotics and there's hardware components, but AI is fundamentally a kind of software. And when you think about software, we used to program it using rules. So imagine a rule of the form: if the moisture is smaller than some value, then you should irrigate. That's the kind of thing that I would teach in computer science classes as people would learn how to write computer programs. What we've learned over time is that instead of these hand-coded rules and programs, we can actually generate very sophisticated models using from data. So AI, now it's called machine learning, statistical learning, deep learning. The lingo doesn't matter. The point is that you show AI data, actually the more the better, and it generalizes from that using various statistical techniques to make decisions and so on. So that is really the basic idea of AI, a new way to create software. Now, this has actually been going on for some decades, but recently AI has taken off. A lot of people got introduced to it with ChatGPT, which fast-growing app. Why did that happen? There are really three things that led AI to really take off in the last few years. The first one is the presence of absolutely massive data sets. So it turns out that one property of these AI systems, where people can get overwhelmed with data, even computer programs can be overwhelmed, but AI systems' motto is the more data, the better. So a tremendous amount of data, all the text on the internet, all the videos on YouTube, all the satellite data you can think of, these all get fit into AI systems to produce very powerful results. The second thing that happened, which enabled the processing of this tremendous amount of data, is computer power, GPUs in particular, but doesn't matter, GPUs, CPUs, basically very powerful computers sitting in the cloud. That means they don't have to be at your desktop or on site. They could be at Amazon or Google or Microsoft's data center. And those, coupled with what's called neural networks, basically fancy statistical algorithms loosely modeled after the brain, can produce tremendous results. And these results, it used to be that when we were working on AI, we would build a model for one single task, like, okay, can we detect whether this message is a spam email or is it a bona fide email? Or can we detect, is there a disease in this image, a plant disease or a cancerous cell versus not? The wild thing about the new models is they're very general, the way ChatGPT is. And that combination of three things, general model, tremendous amount of compute, tremendous amount of data, has led to AI being more useful than ever before and having the potential to really revolutionize everything that we do. So let's talk about the kind of data that AI can ingest. And the TLDR here is it can ingest pretty much anything, structured data. So you can have the results of soil tests, you can have tables and databases with pricing and other statistics. You can have unstructured data. You can have images, audio, video, text. AI is happy to take all of that in. You can have time series data, which is particularly important with agriculture, right? How does moisture change over time? Satellite images, how do those change over time? And then it takes all this data, puts it together, even though it's very varied, to generate different kinds of insights. And the different kinds of insights belong into three main categories. The first one is predictions. Let's say I want to predict disease risk under a certain set of circumstances. I can do that. The second thing it does is classification. Years ago, I built a company that classified airfares as are they going up or going down? Imagine if you could take a stock market stock and say, is it going to go up or down tomorrow? Or in the context of agriculture, you can show it a picture of a plant and it could label it as healthy or stressed. That's classification. And then the third one, which is the most recent and in some ways the most powerful, is what's called generative AI. You don't just make distinctions like healthy versus stressed, or you don't just make predictions like things are going to get better or they're going to get worse. You actually generate. You generate plans, you generate summaries of documents, you generate simulations, you generate software, you generate biological models, tremendous ability to generate sophisticated artifacts that can do things on your behalf. Now, what does this mean for the relatively near future? I'll just mention a couple of examples to give you a sense of this. I won't go through all of these. One is you can have these what if type of simulations. Let's say you're wondering about some decision to make on the farm in terms of crop schedule or what to plant or irrigation technology. So you can actually ask the AI, what happens if I change X? What's going to happen? And the wild thing is you can actually ask it in natural language, just the way you ask ChatGPT. You can literally ask it using speech or typing some text, and it'll give you quite a sophisticated answer. Beautiful thing is if you don't like the answer or if it's not sufficiently detailed, you can ask a follow-up question. You can really get into a dialogue with a sophisticated AI system. Another example, which illustrates the breadth of the technology, is we also have machines and robots that can actually be working in the field. And of course, I think most of you are familiar with carbon robotics, which has laser-based weeding actually on the fields. And the assessments, the decisions to make about what to weed and what not to weed are using AI. So huge diversity of what you can do using this class of technologies. Now, I'm not one of these people to tell you, oh, AI is a panacea. Everything is going to be wonderful. Just, send us your money. We take Venmo. There are plenty of challenges here too that researchers are working on, that technologists are working on, and a bunch of these are not yet solved. So let me mention a few. If you have poor or unbiased training data, there's a saying in the field of computer science, garbage in, garbage out. You get bad data in, the model does its thing, and you can get very incorrect conclusions, or you can get biased conclusions. That's a real problem. For example, AI is used a lot in hiring of technical folks at places like Amazon, and errors were caught where it was refusing to hire women because historically women were underrepresented in these fields. So the machine generalized from this biased historical data and said, let's not hire women, which of course is a huge missed opportunity, not just for the women involved, but also for the corporation. Fortunately, they caught that before it went into production. But this gives you that kind of idea. It can be biased. And by the way, it has no common sense to speak of, right? The machine itself didn't realize, oh, that's crazy. It has the potential to overgeneralize, right? What if it was trained in a particular context, a particular region? It was trained in California on data from California. Now we're trying to apply it to the state of Washington, where let's say there's more rain. Things might look different. Another issue has to do with how people interpret the data. We've seen instances where people are way overly reliant on what the AI says, and they start to believe it uncritically. We've actually seen examples of this in the criminal justice system, of all things, which again had very bad outcomes. So I caution you to be careful and double check what the AI says. So the really important point is that AI will speak confidently often and will even hallucinate things that are not true. And you have to be very careful to check and double check its work. Now, another issue, of course, which many people are thinking about, particularly as AI is becoming more and more widely applied, is the impact on the workforce, the impact on jobs. So there's a whole economic discussion of what is it going to do, particularly in the long term, for people's work. I just want to highlight the fact that at least so far, what AI has changed is it has not gotten rid of jobs. It's resulted in shifts in the kind of tasks people perform. So, for example, think about scouts scouting out the crops in the fields. Often there's a shift from physical labor to data analysis. Maybe the drones are out there looking at the fields, and people either on their laptop in the field or even at a desktop are analyzing the data that comes in. And this does mean that we probably need to start thinking about upskilling and training workers to do this sort of activity, because it's clear, and my understanding is that the history of agriculture over the last decades has been that it's become increasingly sophisticated technologically. Well, this is just a continuation along this path, this time with AI technology. We do need to prepare for that. I want to highlight that we need to do this through a partnership between researchers, say at WSU and other places, and of course at the University of Washington, which having spent 30 years there, I'm very partial to. It's a wonderful place, but also partnership between ag experts and AI folks, right? The real world data and the expertise that's absolutely necessary to put in the right kind of data, to draw the right kind of conclusions, that has to come from the ag experts. And the advanced algorithms and computational power has to come from the computer scientists. And working together, inevitably, I've seen this time and again in many fields, works a lot better than just relying on black boxes. And I'm sure you'll hear more in this webinar and more in even the next talk about collaborations and resources that are available to support this. So I want to conclude by telling you that AI is a powerful tool, and I hope I've given you a little bit of a sense for that, but it is not a silver bullet. It's a power tool. You need to use it carefully, and you need to use it with transparency, establishing trust, and through partnerships to achieve successful outcomes. The last thing that I want to tell you in this context is something about this talk, which hopefully gives you a sense of just how transformative AI is. So the way I structured this talk is I asked Melanie, can you send me a set of questions that you want me to cover in the talk? I wanted to make sure that I addressed the basic things that people wanted to understand. She sent me a very thoughtful set of questions. I took her questions and I went to ChatGPT and I said, well, pretend you're an AI expert. Take these questions and come up with the outline for a 15-minute talk that addresses these questions for an AI 101 for agriculture folks. It came up with an outline. I literally cut and paste the outline, and I put that outline into an AI slide generator that generated automatically the slides you're looking at. Now, to be clear, I didn't just stop there. I did review both the outline and the slides. I deleted some things. I made a few changes. So I didn't just do this automatically. But nevertheless, preparing this brand new presentation took me an order of magnitude less time than it would have otherwise. And I hope you enjoyed it. Thank you very much.
That was great, Oren. I think our next 101 needs to be on how to make a slide presentation. That's fantastic. Thank you. I just wanted to remind everybody that we are going to do Q&A at the end after Ananth talks, and there should be a little button at the bottom of your screen called Q&A with a question mark on it. You might have to look under the More menu in order to get that, but please pop your questions into chat. And the folks that you see on the screen right now are from our planning committee. We have a really diverse planning committee of Washington State Academy members from lots of different disciplines, from policy, from the ag community, and they're going to be monitoring your chat and helping to lead that discussion. So please go ahead and pop your questions in there for us. All right, with that, I would like to introduce our next speaker, Ananth Kalyanaraman. Ananth is I've been saying that all morning, Ananth Kalyanaraman. There we go. Ananth is a professor and Boeing Centennial Chair and Director of the School of Electrical Engineering and Computer Science at Washington State University. He also holds a joint appointment at the Pacific Northwest National Laboratory. His research focuses on the development of algorithms and software for scalable analysis of large-scale data, particularly for agriculture, plant, and life sciences. He is also the lead PI and director of a national research consortium based at WSU that's called AgAID, which is the AI Institute for Transforming Workforce and Decision Support in Agriculture. He and AgAID have been at the forefront of developing and applying AI for agriculture, and he'll go ahead and delve into some specific use cases of AI in agriculture for us. Ananth, thanks for joining. Go ahead and take it away.
All right, so good. I hope you all can see my screen. So it's actually a very distinct pleasure to be at this webinar series, and also one of the first ones, I think, in the series of webinars. I'm really looking forward to not only just the webinar series, but also the symposium that's planned towards the end of the semester. So thanks, Oren. I think you made my job a lot easier. I think there was a wonderful intro to AI in general, all the different things, the way it can be used, and so on. So in my talk, I highlighted, again, I took what Melanie gave me as the prompt, and what AI can do, and where it's going, and what key opportunities there are for agriculture. I tend to stay away from predicting. Right, so where it is going is anyone's guess. Actually, I would argue that where it's going is something for us to decide. We can shape it the way we want. So I would like to basically focus more on what it can do and some of the key opportunities to look for when it comes to AI in agriculture. And I'm going to at least present from the point of view of the AgAID Institute, which I've been leading, or very fortunate to be leading, since the last 4 years. And so we have been basically, this is like a test bed for us, right? So how do you take something that's evolving constantly like AI and see how all the different ways it can be applied? And hopefully my takeaway here is AI, if you ask any person on the road today, what does AI mean to you? They say ChatGPT, generative AI. Hopefully the takeaway from this talk is, AI is a lot more than just conversational or generative AI. Of course, they have now become a lot more integral part, but there's plenty of techniques that you can use, and different kinds of capabilities. So I'm going to show you some examples, basically. And just a very, very high level, what we are at AgAID Institute. We are one of the 29 AI institutes in the nation. Each is an investment from the federal agency, either it's NSF or USDA. In our case, it's USDA. We are one of the 5 AI institutes focusing on agriculture. And we have been very fortunate to be leading this AgAID Institute, and we have excellent partners across the 2 sides of the country. Oregon State, University of California, Merced, and Virginia are our main research partners, and we have been really fortunate to work with plenty of other educational entities, as well as 4-year colleges and community colleges and so on. So let me at least tell you briefly what challenges one can think of, and I'm going to kind of hone it around specialty crop agriculture, which is what you obviously know exists, plenty of it in the Pacific Northwest area. And there are some challenges. When you ask someone from the Midwest, they may come up with a slightly different set of challenges when it comes to AI and how it can be used for agriculture. Most of the specialty crop agriculture that we do here on the Pacific Northwest, the number one thing is the tremendous crop diversity. So what works in one system may not necessarily work in the other system. There's also significant labor that's involved in the specialty crop industry. So certainly, any kind of labor, automation, augmentation is really going to be helpful. And most of these specialty crop industry also are grown on irrigated land. So they do rely on inputs and natural resources, in particular water. And there are also perennial crops, right? So perennial crops, which essentially means that any kind of weather damage that incurs or any kind of damage that happens in a farm, the farmer has to have a long-lasting loss or might have to face consequences which could be significant. And so with this in mind, we started actually looking at the core problems. So we did find, okay, what are the kinds of ways in which AI can help with water resources in general, planning of resources, seasonal scale or regional scale, and also at the field scale, how water is efficiently used. The other major thrust we have is basically on weather, which is to do more with how to come up with intervention mechanisms in a timely manner so that we mitigate the risks associated with any kind of extreme weather events. The third one, obviously, is labor, which is how do we actually come up with ways in which AI and humans can partner on the field so that we can come up with more improved productivity, agricultural productivity. So this gives you a rough context of what I'll be giving or citing examples from. But by and large, basically, like this is actually very aligned with what Oren was also talking about. This is roughly the nature of AI that we have been developing, and mainly AI, how it can be used to mitigate risks, how it can be used to assess and quantify uncertainty, because that's a big part of our decision dashboards. And when we want to make decisions in a robust way, we want to make sure that we capture all the uncertainties that are involved. And how do you augment labor and also add AI as a help counterpart to the human who is working actually on the field. And it's not like we ignore science. In fact, it's a critical part. We need to know the horticultural the knowledge. In fact, we want to make sure that some of the crop features and the agronomic traits are captured within the AI tools. It should not be just purely data-driven. And then AI also can be used for predicting unobservables and the unobserved, right? So, that's the notion of predictive science. And can you go beyond just prediction? Can you also use it in forecasting, near-term forecasting, right? And also using AI as testing grounds, be it with digital twins or simulators or synthetic data frameworks to test scenarios so that you play with AI system and then you actually pilot it in your farms. And finally, of course, the interactive part, which is more to do with Gen AI and conversational AI, how do you interact with the system? So these are all like the toolbox, the color, all the different types of AI that one can think of. And let me show you a few examples. So let's say, on the agriculture labor side. So many of the specialty crops, tree fruits, grapes, and berries, and so on, they are labor intensive. And because they are also perennial crops, it's not like there's just one time you need the labor, right? So you need labor throughout the season. So for example, in this, you're showing, you're seeing basically a blossom thinning, which happens in spring at the flowering time. But also we need to have some spraying applications So how much of it we can develop and how much we can reuse, right? So it's not, maybe it's just the end effectuator that actually needs to change, and how much of intelligence can you embed while using the rest of the platform. This will actually help us transfer many of these. And this is actually excellent work done at the WSAS Center in collaboration with Oregon State. Uh, so the issue with AI and robotics is, the adoption is the problem. And in fact, are we there even when we can actually reliably say that there's good robotic technology? I would argue that they are very much in the research and development phase and piloting. And I think early demonstrations have shown to be quite useful. But by and large, as you can see in this image, both taken in real time, robots are pretty slow. And it's not only that, I think they have a lot more to learn about the system. So when the human expert pruner who is pruning the branch on the left they can see ahead of time, they can say, if you let the branches grow in 2 or 3 months down the road, the branches are going to crisscross and not have enough sunlight but that's something that requires complex decision making and experience. And it's not just about performing a task, but knowing the consequences of the task, which may not be readily observable right away. So this is something that I think we need to work closely. And also, the other thing that it take really to push these kinds of robotic technology to production mode is really interfaces, learning interfaces. If we can even build interfaces that can train a new incoming worker, saying, oh, let's do the digital pruning first before you go onto the farm, that's one way to use these technologies. The other one is really, can you use the digital interface to generate some different kinds of branch architecture and so on, so you're training the robot in different ways. So I think these kinds of pruning interfaces and different learning interfaces are extremely important as the technology continues to evolve. So how can then AI be used for modeling crop risks? I talked about different kinds of weather-related risks. This is one example of it. So what we did was basically we took data from farms, so mainly from the WSU research farms. And there are also AgWeatherNet stations, which are these network of weather stations across the state. The important thing about these kinds of weather-related assessment and risk management is it needs to be site-specific. So the more data that you get from the site, the better the model is going to tell you. So here, to mitigate frost, we basically come up with, can we model how much of a risk the crop is facing when it comes to cold damage, based on all the inputs, like, what's the local weather, what is the kind of crop that we are growing, and so on. So we have already built some models for multiple different crops, but to actually take this and deploy it further, I think the more and more use you'll see, the better the models will get. AI also can be used for some level of seasonal planning. So for example, if I'm a grower and if I want to predict ahead of time at what time the buds are going to break, at what time the fruits are going to emerge, at what time the fruit will be ready for harvesting or some level. So these are all the different developmental stages. In the AI lingo, it's like really predicting what we call a sequential state machine, right? I mean, you're spending some time in a particular phase or a growth stage and then moving on to the next phase. So the timing is what matters. So we have been fairly successful initially, at least, to actually be able to predict some of the stages well ahead of time. Of course, that helps in planning, but is certainly not ready for deployment yet, because we need more data from different farms really to be able to train and come up with better generalizability of the models. AI can also help with filling up missing data. So as an example, let's say you have a bunch of weather stations. Not all locations are weather stations. Maybe you can use AI to actually come up with what we call imputation, or basically this is predicting where data is really not observed. So we have done this for different kinds, to use weather data to assess whether missing data, or even snow data, which is present in different places. So you can think of AI as really a space filler. What is very, very physically sparse in the observed layer, you can make it dense in the digital layer. So you can actually work with this information that you have at the digital layer. In terms of uncertainty in the decision making, so for example, here is one work that we did, which is on how do you predict snow water equivalent. It's a term on how much snow is sitting on the ground and at what rate it's going to melt. If you can basically use these advanced machine learning models to be able to forecast at what rate snow is going to melt in the next week or next 2 weeks. That will tell me how much water I'll see in the stream flows, and that will tell me how much water will be available throughout. So that's the nature of the forecasting tasks here. We can also use AI for fusing data with scientific knowledge. So, for example, similar to the snow, we also have developed some models for stream flow prediction, and this requires us to model a watershed, like a network that you're seeing. But importantly, we need to make sure that the physical constraints of water, how much water comes in, should be approximately equal to how much water goes out. It should be physically consistent. And so there is a way to actually encode some of those physical constraints as part of our machine learning models, so that the output that AI gives is scientifically consistent. And that's important for many of these process-oriented applications. When it comes to querying knowledge bases, AI can be tremendously useful. We have developed some basic interfaces for portrait animated incidences, and how can we use that to query against vetted out scientific literature. So we don't have to worry about really putting all the resources and understanding the scientific literature, but AI becomes really an accessible interface into something that's well documented. For all this, I would say that test beds are going to be extremely important, regardless of what kind of project we take on. So in other words, what we do piloting, we need to test out in real environment. It's one thing to test in research environments and research farms, but they're not necessarily maintained to the commercial practice. So it's actually, we need really commercial growers who are ready to pilot some of these technologies. And we have been very fortunate with the support of Washington Tree Fruit Research Commission to actually have multiple different projects along this. The Smart Apple Orchard is an excellent example of this, where a couple of growers in Mattawa and Zilla, their farms have been instrumented, and we collect data. We can actually test out some of these sensing technologies and AI kind of intervention mechanisms in commercial blocks. And that actually goes a long way. And so this is the list of all the different public-private partnerships that project has generated. And this is excellent to see. And we see this as a growing opportunity. The other thing really is to ensure that education extension are core part of the research exercise. Because it's not just, oh, let's do something in the labs and deliver it. That's not going to work. So in fact, like the Smart Orchard Field Day projects, we have talked about it as, okay, we have actually done a number of field days, grower education, but also getting input from them, because they know a lot more about the system than we as researchers do. What can we learn from them? How do they interact with the system? All that is extremely important. In addition, I would argue that K through 12 education is so important when it comes to agriculture and AI. These kids grow up in rural communities. They have seen the farms in the backyard. They understand the agricultural systems. They are also very tech savvy. So I think it's the ideal combination of traits that we can target. And if this group of kids can grow up to be our next generation ag tech people, I think we are in good hands. This is roughly where I see in terms of where we are. I think we are in the early demonstrations in agriculture for something like AI. AI is a tool, like Oren rightly pointed out. It's for us to use the way we want. And so I think there are multiple different things that I would like to see at least. I'm open to suggestions and ideas, and this has to be a community-driven effort. So how much of AI can we take it from farm to table? And what kind of generative techniques we can use in a reliable way, right? So that you can generate a basic model, like a foundation model, and then apply it in different contexts, and it needs to be trained at the different locations and using different kinds of system data to make it useful. And how much of AI-ready experimental test beds we can put in place. I think this requires consortium, different kinds of consortia. Cybersecurity and privacy are huge concerns. On one hand, we are saying use more AI and hence more digital tools, but we are also exposing more vulnerability in that process. So can we make it trustworthy as part of the development process? How do we scale AI in a very responsible way? And it's not just labor, but also knowing what we are getting, and so that we know where best to invest in human resources. And then generating or preparing the AI-ready workforce is a major challenge. So these are all the significant amount of work to do. I'd like to just point out some of the challenges and the opportunities in this area. So I'd say, when it comes to the AI side, how much can we put the models to use in very specific ways, and site-specific ways, a clear challenge. Transfer learning and doing test time learning, making the models adaptable so they learn on the fly is going to be extremely important here. Creating human AI interfaces are important. Ways to share data, I would argue that agriculture is still by and large a medium scale data, and it's not big data yet. But the variety and the richness and the diversity is what makes it strong. So the question is, what can we put in place so that it makes it easy for us to share data without worrying about the privacy and the cybersecurity, and that needs to be kind of built into the tools. And adoption rates, this is cited as one of the major costs of, our AI adoption rates sufficient, right? So scale neutrality and translational AI emphasis is very, very important here, and workforce preparedness. So like one of the main underlying things is also that there is shrinking federal funding in this area, despite all the importance to AI as well as agriculture. So I do personally think the path forward is really truly a partnership oriented between like a model between academia, private and public partners. And then given the farming community is also very regional, we should think about regional innovation hubs. What works in California or what works in Virginia might not necessarily work here. And I think the development, it has to be engaging with the rural underlying communities. So I know I'm out of time, but I do want to really leave you with this kind of at least a food for thought for future, how we should imagine a future, I think, when every farmer has a digital twin of their farm or orchard to reliably evaluate, to be able to test out for the entire season, capture all the uncertainties. Every worker comes into the farm, walks in knowing that their skill set is valued and their productivity is amplified with the use of technology, not feeling threatened by it. Every regional policymaker should have the right set of information to make robust decisions for planning and infrastructure. And every kid growing up in rural America should have an opportunity to build a career in a hot area like AI or AgTech and basically contribute to the system. So I do think that there is a moral imperative for us to work together on this. And with that, I would like to thank all the sponsors. And I really like the fact that Washington State Academy of Sciences is prioritizing this topic. So thank you for that.
Thank you so much, Ananth, and thanks, Oren, and thanks everybody for hanging in. Despite the amount of information there, of course, we're only scratching the surface right now. So you will see a few follow-up resources, high-level resources, if you want to read more about uses of AI and ag and some of the main types of AI technologies. I think I'm going to just jump right into questions. Again, thank you very much. Oh, I love the audience clapping. Yes. We have some of the members of our planning committee online, as you see at the top of the screen, and they've been monitoring the chat for the Q&A as they've been coming in. And so I'd just like to turn it over to our planning committee to help pick some of the questions off of there and kind of combine some of the ones that you see that might fit together so we can get to as many as possible in the next about 10 minutes. So with that, I will look for hands up of the planning committee. Ed.
Well, absent other hands, I'm going to elevate a conversation I've been having with John McNamara from WSU. And, the question is, what are the unique characteristics of agriculture in Washington? Because I think while Ananth's collection of centers is focused on the national ag picture entirely appropriately and positively, we're focused on Washington State. And so are there particular characteristics here that we should focus on in terms of the AI that's going to benefit Washington agriculture? Do we have a particular position in specialty crops, high value crops, farm size, the sorts of things? Are apple picking robots going to be a dream for the next 20 years, and that's not a place to spend time, and on and on. So the
That
question is, what's unique about Washington that we
That is
can
the
take?
key question, Ed, for this initiative. And for anybody interested in a longer answer to that, please tune in January 23rd when the director of the Department of Ag and the head of the Washington Tree Fruit Commission will be with us. But Ananth, why don't I turn it over to you for a 30-second quick answer to that?
Yeah, so Ed, many of the things that we at least highlighted are very relevant to the Washington agriculture context. In fact, specialty crop, big time, like you rightly pointed out, there's labor issues, there's water issues, there's certainly different kinds of weather inputs that become relevant here. So most of the work actually that we did is all rooted very much in the Washington State agriculture, even though it's a national institute. There is also other kinds of problems in like Michigan and Florida and so on for other kinds of specialty crops. But we have predominantly focused on Washington State agriculture and a little bit of California and Oregon systems too.
I will go ahead and ask one. Thank you very much. Oren, especially for you, you showed one of the risks of AI was the person with their blinders on and just blindly trusting AI. And you said AI can hallucinate it, it can be wrong. And I've been starting to play around with AI, and I've definitely noticed this myself. But what should I be doing? What questions should I be asking myself? Or what questions should I be asking the AI agents to know what to trust and to find those errors?
I think the first thing to do, and Melanie, sounds like you've already been doing it, and really everybody should be before our kids get or grandkids get way too far ahead of us, is to have AI literacy, which that's fancy words for you got to play with these systems, you got to try them and see what they're good at and what they're bad at. And the best place to try them is something that you're very knowledgeable about, whatever it is, whether it's, I don't know, wine or whether it's computer chess, doesn't matter. That's the place to start. And so you can see where it gets things right and gets things wrong at a place where you're the expert. Once you have a sense of that and you see what some of the pitfalls are, the next step is to have it expand your knowledge, enhance your capabilities, take it to places where you don't know the answer or where it could be improved in various ways. But then you have to ask yourself, okay, what's my plan for verifying, corroborating the things it says? And it can be as simple as when it gives me a link to something, I click on the link and make sure that it's real. That was the problem with the lawyers that submitted AI generated briefs that made up a bunch of stuff, right? So maybe a metaphor is helpful here. Think of AI as a hardworking, super smart, incredibly eager intern who's always ready to work for you, but actually came from Mars, right? So they're a little bit out of whack in how they think about the world. So again, definitely, hey, they want to work, they want to help you make use of it, but be a little bit careful that they don't send you over a cliff.
Interesting. Thank you. That's great. Appreciate it. Okay, we have some hands up. Jordan, I'll go to you.
Thanks. There are several questions in the Q&A related to smaller producers, smaller growers, both from an equity and access standpoint and also just from a practical standpoint. Like which of these tools are going to be most useful for smaller growers, smaller producers, and how can we help ensure access to them? What are the first steps? And which do you think will get uptaken first?
I can take a quick shot at that. I think at least when it comes to AI, I see it as two components roughly. One is software, right? So the other one is more on the hardware and robotics and things that require much more of a higher capital. So software is arguably easier to provide service for, right? So, it comes, of course, it adds up over a period of time when it comes to subscription of these services. But I think there is, to the extent possible, we embed the services as apps and things like that in an ecosystem that farmers are already using. I think there is clear value in it. When it comes to real hardware and investing in robots and there has to be a capital, and that's where I think that being scale neutral to the extent possible, transfer of technology, all this comes really important, right? So to reuse of repurposing one that was a robot which was for picking, can I use it for spraying or can I use it for like pruning and so on? I think becomes really an important question there. So.
I just
Thanks.
want to chime in and add an important point that's more generic, but it's really important. AI is not necessarily expensive. So as Ananth pointed out, of course, if you have a very sophisticated robot on your farm, that might be a significant expense. But there's a lot of open source code. There are a lot of creative ways to fine tune and use even something like ChatGPT or Claude. So your mindset shouldn't be, you have to be Microsoft or IBM to use this. Your mindset should be, what's an experiment that I can do quickly using the data that I have sitting on my laptop or that I have access to from my sensors. And because I do a lot of work with startups for many years, always see new technology as a potential for disruption. How can the fact that I'm more nimble, how can that allow me to use AI in ways that maybe big growers aren't thinking of yet?
Interesting. Thank you, Oren. Danny, I'd like to go to you, Washington Department of Ag.
Yeah, hi. You both raised really exciting possibilities for AI to solve some issues, but I thought maybe we could talk a tiny bit about some of the consequences it could pose or some of the challenges. There's a lot of story about data centers putting pressures on water supply or on land development, which of course are already scarce resources for agriculture. So I'd love to hear your perspectives on those issues and how we in this room, both decision makers, farmers, scientists, can kind of mitigate those consequences and optimize the benefits.
I'll start with 2 points. The first one is AI does need to become much more efficient. So about 5 years ago, I and some colleagues at AI2 and in University of Washington wrote an article calling for green AI. And green AI didn't mean AI used in agriculture. It meant AI that's a lot more efficient in its carbon footprint, water use, etc. The good news is that many people have heeded the call, and also independently of it, the cost of AI algorithms is dropping by a factor of 10 every year, not factor of 2 like in Moore's law, but very, very quickly, and that's resulting in drops in price and so on. So the notion that there's this kind of tsunami of resource consumption, there may be a significant increase, but it's due to literally hundreds of millions of people starting to use it that didn't use it before. The technology itself can be extremely efficient. And of course, things like water use, right, can be mitigated by the reuse of water, et cetera, et cetera. So I think that an appropriate response is to focus on making the technology itself a lot more efficient. A second point, though, is to understand the quantitative aspects. And again, I'm not an expert on this, but I'm a little bit surprised to hear that kind of data center use and some of these, for example, impinges on land use. Because at the end of the day, even though we have these massive data centers the size of multiple football fields, that's nothing in the scheme of things. So I think we also need to be careful not to be swept up in not that you are, but I'm saying that the general public certainly can be also swept up in a negative hysteria. Oh, AI is coming for our jobs, our fields, our I don't know what.
Thanks, Oren. I'm looking at the clock and I'm looking at how many questions we have left and realizing we're not going to get to most of them, but I want to just open the floor for 30 seconds of closing thoughts if any of you, if Ananth or Oren have them before we do a quick closing on the webinar.
A silence. Somebody once said about me, a microphone is not safe within 10 feet of Oren. So I'll say something real quick and then I'll hopefully give you a chance to chime in as well. I think that it's really important for everyone on this call, and I really say this with strong conviction, whatever you are, whether you're an academic or you're hands-on on a farm, to get hands-on, become AI literate, because a line that hasn't been mentioned, but I repeat as often as I can, you're not going to be replaced by AI, but you may well be replaced by somebody who can use AI better than you can. So don't be that person. Learn how to use it, how to make your whatever you're doing more efficient and more effective.
Excellent point. Thank you. I'm working on it. Ananth?
Yeah, and what Oren mentioned actually applies to also computer scientists. Ironically, so not many CS people are okay. AI is the next new thing. Some people believe it's a hype. Actually, there's clear case to become as literate as possible. With the use of technology, I think it can really improve productivity. But I do want to also leave people with like what are the new things that AI can do that we are not solving. So by and large, I think what we have done is scratching the surface and solving yesterday's and today's problem in agriculture using the use of AI. That's basically where we are right now. How does a future farm look like, and what are the things that we would like to really see? I think that requires a whole community vision, and I do think that's where I think it really is an AI and agriculture is truly like a right at the intersection of communities working very closely with academia and private partners. And federal funding and state funding and all that needs to line up with that. So it does require a holistic community vision.
Thanks, Ananth. That's exactly what we hope to do together with all of you here through this webinar series and follow on development of grand challenges. Thank you, everybody, for your amazing questions. We are actually going to save those and think about how we can answer them in future webinars.